Well, hello again, and welcome to the VK6CS amateur radio channel. I currently have my HF antenna configured the way a lot, if not most, radio amateurs do, and that is that I've got a one-to-one balun, or a balun, at the antenna feed point, and then a coaxial feed line coming into the house where it goes into an antenna tuning unit, more accurately an antenna matching unit next to the radio, because it's matching the impedance, it's not tuning the antenna, although they're called antenna tuning units or ATUs. So the way I normally do it is to have an automatic ATU at the I'll use that term because that's the term that's generally used in amateur radio. I have an automatic ATU at the antenna feed point connected to the 50 ohm coaxial cable into the house, and then that connects straight to the radio, so there's no tuner in the house, and that's the most efficient way of doing it. This way, having the tuner at the radio end, so you have a radio, then you have an ATU, and then you have a 50 ohm coaxial cable going out to the antenna feed point, does work. It is a little bit of a fudge, but you know, it's a compromise that most people are happy with, because it's easier than doing it the other way. It's not as efficient, of course. Okay, so I thought I'd compare this tuner here, which is an MFJ945E, and this one here, which is one I made some time ago. It's got high power components in it, but it's not, the wiring in it is not really suitable for high power. I just threw some high power components in a box so I could play amateur radio. This was many years ago, back in the UK. As you can see, it's still got my UK call sign on it, G0GUS, which is still current. I still hold that call sign. I've held that since that particular one since 1987. Now, the difference between the two types of tuner, this one here is an SPC, a series parallel capacitance tuner, and the little MFJ is a T-match. The difference between the two, if we look at the schematics, or the electrical component layout of the two, we've got the T-match at the top there. We've got the SPC at the bottom, and as you can see, they look very similar. If you see them side by side, the T-match and the SPC, the T-match is called a T-match simply because you have an inductor, which is the vertical part of the T, and you've got the capacitors, which is the horizontal part of the T. So that and that looks like a T, so it's called a T-match. And this particular configuration of T-match, where you've got two capacitors and one inductor, this is a high pass arrangement. If you had it the other way around, so you had a capacitor there and two inductors, that would be a low pass arrangement. The SPC, the idea of having this extra capacitor here is that it shunts any frequencies that you're not interested in throughputting down to deck. So this works better than the T-match for filtering your output. These two capacitors here are on one shaft. So when you turn the knob on the capacitor, both of these capacitors operate. This is the SPC match, series parallel capacitance, because you've got two series capacitors here and one parallel capacitance in parallel with the variable inductor there. Again, that can be variable or switched. Variable's better. Switched is harder to do. It's harder to make, and of course you might find that the perfect inductance is somewhere between the taps, whereas if you've got a roller inductance, you can always optimize. You can optimize it, no problem. So that's the T-match and the SPC. That's an SPC, and that's the T-match. Right. Okay, well now I'll show you the difference in matching responses between the two tuners. To do that, I think I'll put the camera on a tripod. So I'm just going to pause this for a sec. Okay, right. Now it's currently connected to the MFJ 945E, and if we look at it, we can see the yellow curve here is the impedance curve showing 50 ohms. That's the impedance curve. The white curve here is the SWR curve, which is 1. If you look at the scale here, this is SWR 1 to 5, and on the other side the impedance 0 to 300 ohms. Now just before I do that, I can actually switch this tuner out, so I'll do that. That's what the antenna looks like with no tuner in circuit. So that's with no impedance matching whatsoever. It's showing it's 240 ohms. You can see there, 240 ohms. SWR is 4.6 to 1, and if you look up there, the lines are corresponding with that. Now put the tuner back in, and there we go. Right, now we've got a sweep width of 500 kilohertz, so from one side to the other it's 500 kilohertz, and we have center frequency 7.093 megahertz, which is the WA chit chat channel of choice. And there's me sounding like a disc jockey. Where are my NAB carts? So you got 7,100,000 or 93 kilohertz. So by changing this last number here, I'm changing them in 1 kilohertz increments. Righty ho. Now I'm only going to be QSYing HF, because I don't do CW. I did learn CW and pass a CW test, a Morse test, back in the UK, back in 1987, to get my UK A class amateur radio licence. But I've never ever used it on the air. It was just a means to an end in those days. You had to have Morse to get on the HF bands, and I thought I'd... A couple of friends of mine passed their Morse test and they had full licences, and I had a B licence, which I got in 1981 along with those guys. I didn't want to be left behind, so I thought, okay, well I'll bite the bullet and I'll learn CW. But never ever used it. Personally, I've always thought that Morse is something that grows around posh people's duck ponds. I've never really seen anything to it. You know, people have said to me, "Oh yeah, well if you were in a submarine and it had a problem and it settled on the seabed, you could hammer out a message on the hull." You know, and I thought, well, that's really useful. Next time I'm sitting on the seabed in a submarine, I'll bear that in mind. I'll probably be able to. It will suddenly all come flooding back to me. As long as what's on the outside of the submarine doesn't come flooding towards me, of course. Okay, right. Now, this blooming tripod, it's always in the way. But here we go. So 7093. So we go up to 7100. There you go. So that's 7 kilohertz. No problem. SWR1. Impedance is 50 ohms. So we go up to 110. There we are, so that's 17 kilohertz. SWR is 1, impedance is 50 ohms. You certainly wouldn't see this on a magnetic loop, this sort of broad tune. So you can QSY from 7093 to 7110, and just in your comfy chair. You don't need to twiddle any knobs. You can just QSY and carry on the chat. We go to 720. How does that look? Yeah, it looks fine. 1.1 to 1. So it's gone up a little bit, but it's not significant. Impedance is still 50 ohms. And we go up to 130. 1.2. 50 ohms. As you can see, this the white SWR line here, as it's moving across our vertical line, which is showing our centre frequency, is moving up the line. So that's why the SWR is going up. The impedance curve is the yellow one. That looks reasonably flat at 50 there, so that's staying at around 50 ohms. So we'll go up another 10 kilohertz. There we go. That's 7.140, 1.2 to 1. Still 50 ohms. Go to 150. There we go, 1.3, 50 ohms. So you still wouldn't need to do anything about that. You could just QSY straight up to 150, or 153 actually is another chit-chat channel here in WA. 1.3 to 149 ohms. So you could still remain in your comfy chair. You could just QSY and continue the QSO. That's interesting. I'm using the Q code, which was developed for CW, for Morse, and after what I just said about Morse. But there we go, force of habit. Actually, I don't use the Q code all that much, not as much as others. But then I don't do a great amount on HF. All right, well, let's move up in frequency still further. So we go up to 160, and then up to 170. 170, 1.4 to 1, 47 ohms. You still don't really need to do anything about that. Anything above 1.5, I'd start looking at nipping it in. But I'd say that looks fine. And that's a really nice broad tune. You know, so we've gone from 7093 to 7170. So that's what, 63 kilohertz. No problem at all. 67 kilohertz. So that's really quite nice, and that's the little that's the little MFJ tuner. Okay, well, I'll just put that back to 7093. 7093. There we go. And I'll pause it, and I'll connect the antenna analyzer to the larger ATU, the high power SPC type ATU, and we'll see how that looks. Now, before I do that, I'm just going to point something out to you, and that's this impedance curve. See the impedance curve? Comes up like that. So it's nice. It's a nice smooth curve. Comes up, it's reasonably flat along there for the 50 ohms, and it goes down again, so it's going like that. SWR curve is coming in like a V, and the impedance curve is the other way up, so it's drooping down on each side. And with that, I shall pause it and connect it to the other tuner. I'll see you in a sec. Alright, back again, and the analyzer is now connected to the big tuner, the SPC type. And the first thing you notice is, there's my pencil, try and get here without nudging the bloody tripod, that the impedance curve is the other way up. See that? You've still got the flat bit across there, 50 ohms, but on either side it's going up. It's not going down, so that curve is the other way up. Okay, well let's see if there's any other significant differences. So let's first of all change the frequency from, we're starting again at 7093, everything else is the same, still 500 kilohertz across. We can see the SWR is 1 and the impedance is 50 ohms, so that's that matches fine. Be perfectly happy to connect my radio to that and use it. On 7093, 7.093 megahertz. Right, okay, let's wind it up to a few kilohertz there. Let's put it up to 7.1. Still SWR of 1 and 50 ohms. As you can see, that response there, that looks pretty flat across there, that 50 ohms region of the impedance curve there. Let's turn it up a little more, go up in frequency a little more. Oh, what was the terminology I used before I hit the pause? QSY. QSY up the band a little bit further. So let's go up to 110. Okay, so we've gone up to 7.110. Still SWR1 and impedance is 50 ohms. It's 7120. 1.1, 49 ohms. Still nothing to worry about there. Solid state radio, be perfectly happy with that. Go up to 7.130. 1.2, 49 ohms. Again, that's no problem. 7.140, 1.3 to 1, 49 ohms. 1.4 to 1 at 7.150, still 50 ohms. We'll go up to 153, the other chit chat channel. 1.4 at 50 ohms. So you could QSY from 7093 to the other chit chat channel 7.153 without worrying about the tuning, without retuning it at all. So that's no problem at all. They're very similar. You know, the actual width of the tune on both of these units is very similar. You know, if you're wandering around a hamfest and you see these great big tuners and you think, wow, you know, having one of those would be great. Well, unless you're going to run a lot of power, it's going to make very little difference. Well, it's going to make no difference whatsoever to the actual tuning compared to one of the little MFJ tuners. So if you don't need a great big tuner, it's not a problem. And because somebody's got a great big tuner and you've got a little tiny tuner, just remember, you know, it's not the size of your tuner, it's how you use it. Okay, so let's go to 160, 7.160, 1.5 to 1, 50 to 170. I think that might be slightly, well, it's getting above 1.5, but I said anything above 1.5 nip it in. But that's gone to 7.170 now, 1.6 to 1, 50 ohms. So that's probably a slightly broader, this one, I think. I should have made some notes, shouldn't I? In typical CS style, I've just turned the camera on and got on with it without doing any prep. And that's 1.7, 55 ohms. So yeah, I wouldn't be connecting, I'd retune it at that point. But certainly that's really quite a broad match. So 1.5, 50 ohms, 7.161 from 7093. So what's that? That's 68 kilohertz. So that's pretty damn good, isn't it? I think. Now magnetic loop is not going to be anywhere near that. I'll show you that, but not on this video. I haven't got the loop set up at the moment. Otherwise, I could just put this on the loop, and you could see how narrow the bandwidth of the loop is compared with this arrangement here. Now, because the loop, what I'm doing here is I'm matching the antenna outside to 50 ohms with these matching units. With the loop, it's a different thing altogether. You actually tune the loop. It's actually a tuned resonance circuit connected to a 50 ohm coaxial cable, which will come back to the house. So there's no matching as such. You know, you just, once the loop is tuned, that's it. The matching is done in the matching transformer at the feed point of the loop, but not usually with an ATU. Sometimes with an ATU, but generally not. But I'll show you that on another video. So I'll just put that back to there, and you can see how much useful bandwidth you've got. Now 40 meters extends out to 7.3 megs, but I think we have it on a secondary basis from 7.1 to 7.3, and up the top end there you get the broadcasters in there. So that's probably why most people sort of stick around between, well, in WA anyway, between 7153 and 7093. Okay, well, I think that's it for looking at the match between the comparing the match of the big tuner to the small one. That's with my my HF antenna outside, so that is a real antenna that it's connected to. So I hope you found that interesting or informative, or both, and as always, thanks for watching, and I'll see if I can do a similar thing for the mag loop and show you how narrow that is. and how far you have to go up the band, or how far you can